In this video, we are going to learn how to plot points using polar coordinates. So, polar coordinates are different from rectangular coordinates, which are x, y, but this time they give you r theta, where r is just a radius from a pole, which usually is just a point. So, how far away is another point from a given point? So, if you want to think of this as an xy coordinate, the pole would be the origin, and the radius would be the distance from the origin. And then it'll also give you an angle theta to see how much it rotates from the polar axis, which if you're thinking about the xy axis, the polar axis is like the positive x-axis. And it rotates around from that ray to give you where that point would be. So to show you how this works, we're going to plot each of these 4 points, and I'm going to label them A, B, C, D on the grid. So this is what a polar grid looks like. You'll see all the circles are the different radii from the origin. All these other little lines pointing out from the center help me find the angle I'm looking for. In this case, each quadrant is split up into 6 equal parts. So if you think of 0 degrees to 90 degrees, it's like 15 degrees each, which will put the second tick mark at 30, which would be pi over 6. And then pi over 4, and pi over 3. And the top one would be pi over 2, and so on. This would be 0. Just so you understand where everything's sort of located. With the one right here being pi over 12, but like 15 degrees, being that smallest one. So if I wanted to plot the points 3, 5 pi over 3, well, I know it's going to be on the third circle out, a radius of 3, and it's going to rotate around that circle 5 pi over 3, which is in my fourth quadrant, about right here. You'll see here, if I go straight down from that circle, I land on this angle point, and it'll be the radius of 3 out from it. So 3, that is where point A is. I'll do all of these in a different color too, so maybe that'll help it stand out on the graph. But cool, point A, I rotated to the points. You kind of imagine where it's at, and it just rotates all the way around to create that angle that you're looking for, which is 5 pi over 3. Let's try another point. So let's say we have 2, we have a negative angle. Well, that just rotates the other direction. So it's the radius of 2, and it rotates downward pi over 4. So this is 1, 2, 3 up for pi over 4. So I'll go 1, 2, 3 down. And point B would be at 2, negative pi over 4. So rotate down 3. So this is where negative pi over 4 is. And then a radius of 2. So that point there would be where angle point B is. Again, it's just that rotation. Negative pi over 4 downwards to get there. Now, where's the coordinate 3, 0? Well, if there's no angle, it stays on that positive x-axis, the polar axis. And that point would just be 3 away from the origin. So 1, 2, 3 for point C. And then lastly, if I want to do point D, this one has a negative radius. So what does that mean? Well, what you would do is you would rotate 2 pi over 4. But instead of going outwards 2 along the angle, you'll actually go in the opposite direction. So even though that's where the rotation would bring you to pi over 4, you would actually go opposite down the other axis to find that negative radius. So negative 2 would be 1, 2 away on this side. So even though pi over 4 would rotate you to that point, we're actually going to go in the opposite direction because of the negative radius for that point. So that's how you graph on polar. You see what radii you'd be out on, and you rotate to it. And if it happens to be negative, you just go straight across through the origin, the pole, to the other side. But now let's plot, and you'll start to see that you can actually represent one point with several different versions of that point. So here I'm going to plot the point for 3 pi over 4. So 3 pi over 4 would be the second quadrant right in the middle. So 3 pi over 4. and 4 away. So it'll be 1, 2, 3, 4 away from the center. And that's my point. You'll see that from the positive x-axis, which I usually use as my polar axis, it rotates 3 pi over 4 to get there, and that's where the point lies. Now, I want to find other polar coordinates of this point for which the radius is greater than 0. So 4, sorry, I have that. But the angle is between negative pi over 2 and 0. So I'm using a negative rotation. So negative pi over 2 would be the clockwise rotation all the way back to the origin. So I'm looking for what is this rotation in this direction. Well, it would be more than pi, and then another pi over 4. So 5 pi over 4 in that direction. So for part A, the point would be 4. But rotating the other way, that's negative 5 pi over 4 in the other direction. Part B, I want to use a negative radius, but still keep my angle between 0 and 2 pi. So it means that I need to use a negative radius. So if I go across, I need to rotate first to this axis here, and then go in the opposite direction. So I know that my r is going to be negative 4, but what's that rotation between 0 and 2 pi that lands me on that spot at 7 pi over 4. So I'll do negative 4 comma 7 pi over 4, and that still represents that same point because now I'm going opposite from it with that negative radius. Now part C, I want a positive radius still, but I want more than a 360 rotation. So I need to go full 2 pi and then a little bit extra. Well, that little bit extra is already 3 pi over 4. So in order to find the full rotation, I'll just take 3 pi over 4 and add another 2 pi to it. So I'll get 3 pi over 4 plus 8 pi over 4 to get a common denominator, which is 11 pi over 4. So that point would be 4 comma 11 pi over 4. So you're going to learn that you can always just add or subtract 2 pi to end up where you want to. Another way to get this angle here is to subtract, for part A is to subtract 2 pi to end up there as well. If I would have done 3 pi over 4 minus 2 pi, that would have also been negative 5 pi over 4. It's only when you're dealing with this like negative radius, those are often 1 pi apart from each other. So in this case, I added a pi to this angle. So sometimes you'll have to add or subtract pi and use the opposite angle just so you can find another one. Now let me use that technique in this next problem so you can see how I can do these a little bit quicker than just kind of guessing. So here I'm going to plot this point. So first I'm going to rotate to negative 2 pi over 3, which means I'm rotating this direction. So 2 pi over 3 would normally be like up here. So negative 2 pi over 3 would be about right here. But it's also a negative radius, so I go in the opposite direction of it, 1, 2, to right there, which is, that point would be negative 2 pi over 3. So first I want a positive radius but a negative angle. So I want to use a positive 2. So I need to rotate another pi from negative 2 pi over 3 to get over there so that I can use a positive angle, but I'll still get something that's less than 0. So I'll do negative 2 pi over 3 minus pi, which gives me negative 5 pi over 3. So 2 negative 5 pi over 3. Part B, negative radius, which I already have, but an angle that's between 0 and 2 pi. So I can't use this angle, but I want it to still be between 0 and 2 pi. So what I can do is actually just rotate this around by 360, meaning I'm going to just add 2 pi to 2 pi over 3. which is going to give me 4 pi over 3. So negative 2, 4 pi over 3. And that's in between 0 and 2 pi. And now when you say positive radius, but I want it to be between 2 pi and 4. Now this angle here is already pi over 3 with that positive radius. So I need to get another rotation. So I'm just going to add 2 pi to pi over 3, giving me 7 pi over 3. Again, all four of these coordinates represent the same points in polar coordinates. And that is how you plot points using polar coordinates.